So for digital signal processing assignment, the first task given is we need to compose the square wave, triangle wave, and also the sawtooth wave by using the sine wave with frequency of 1 Hz and plot each harmonic and approximated wave. So at first, we need to plot the sine wave by using the sine lat. Which is, I've already written the code here. I've assigned the time in the interval of 0 to 10 seconds, and each step samples is 0.01 seconds. The frequency is 1 Hz, and then X indicates the sine wave, which is equal to sine 2 by ft. F is the frequency, T is the time, and then when we execute, we will get the sine graph with 1 Hz, and also the amplitude of 1. So to compose the square wave by using the sine wave, by using this sine wave, we need to find the formula, where the formula is given from the link here, which is written here, Fourier analysis. Using Fourier expansion with cycle frequency f over time t, an ideal square wave with an amplitude of 1 can be represented as an infinite sum of sinusoidal waves. So the formula given is xt equal to 4 over pi times with the summation of k equal to 1 to infinity sine 2 pi times with the 2k minus 1 ft over 2k minus 1. F is the frequency, t is the time, and the k is the harmonic. So in this assignment, I'm using the k equal to 1, 2, 3, 4 until 6. So by substitute the k equal to 1 until 6 into the formula here and sum up all the harmonics and execute, I will get the square wave. Looks something like that. So based on the code written here, the red color line indicates the square wave, and then the other color line is the harmonics. And then same goes with the triangle wave, which given the formula xt equal to 8 over pi squared times with sine 2 pi 2k plus 1 ft over 2k plus 1 to the power of 2. And then substitute the harmonics k equal to 0 until 6 into the formula and sum up all the harmonics, and we will get the triangle wave, which looks something like this. Against the red color line indicates the triangle wave, and the other color line indicates the harmonics. And then the last one, sawtooth wave. Also we can get the formula, which is written here. A sawtooth can be constructed using additive synthesis. The infinite Fourier series x reverse sawtooth t equal to 2a over pi times with the summation of k equal to 1 until infinity negative 1 k sine 2 pi k ft over k. F is the frequency, t is the time, k is the harmonics, and a here is the amplitude, which in my assignment the a amplitude is equals to 1. So back to the sine lab. The sawtooth coding, also the same time is equals to 0 until 10 seconds, and each step sample is 0.01 second, frequency is 1 Hz, and then substitute the harmonics k equal to 1 until 6 into the formula and sum up all the harmonics and execute. We will get the sawtooth wave in the reverse form, because the formula given is in the reverse form, which looks something like this. The red color line indicates the sawtooth wave, and the other color lines indicates the harmonics. So to check whether my result is correct or not, just Google search the function as sums of sinusoids. So this one is the square wave as a sum of sinusoids. This one is a triangle wave as a sum of sinusoids, and this one is a sawtooth wave as a sum of sinusoid. This one is not in a reverse form, and in my case it's in a reverse form. Okay, so the second task is record your voice saying my name is in wave format. So previously I've already recorded my voice in a wave file. And then the third one is use Lab console to do the following. First, load the wave file by using the wave rate command, plot the sound signal by using the plot command, and print the wave file sampling frequency and bits rate. So back to the Lab. I've already written here. This command comes from here, which the syntax YFS bits wave rate file name. FS is sampling frequency, bits is a bit rate, and then the wave rate is command, file name is the location of my wave file. So my wave file is saved in my desktop, and then I just put the location to this, and then subplot, and then plot 2D. This is the command to plot the signal, and then I run the graph. I will get the graph like this. Okay, so this graph shows that this graph shows that my name is Yam Car. These are the sound signal graph. So to get the sampling frequency, we just need to type fs. So this shows that my sampling frequency is 48 kilohertz for this sound signal, and then the bit rate is 16 bits. Alright, thank you.